Hi, I'm Clayton. I'm the kinematic expert.
And I'm Isaac, and I'm the Newtonian expert, and we're doing trap shooting.
An important factor of trap shooting is speed, and speed is the rate of change in an object's position, such as BBs coming out of a gun. Another big factor is velocity, which is speed and direction. Now, the difference between speed and velocity is that velocity gives us speed and direction, while speed is just the rate of change in an object's position. Now, acceleration is the rate of change in an object's speed. An example of this is the clay pigeon accelerating and decelerating because of the thrower, gravity, and friction. But what is friction? Friction is the resistance between two surfaces, and in trap shooting, it's the resistance between the clay pigeon and air resistance, also known as fluid resistance. Now we're going to calculate the average speed of the clay pigeon. Let's get to writing. In the video, the clay pigeon went 31 meters in 2.7 seconds. With sig figs, that should equal 11 meters per second.
I'm Isaac. I'm going to be the Newtonian expert for today. We're going to tell you how Newton's first, second, and third laws affect trap shooting. First law, also known as the law of inertia, states that an object in motion stays in motion and an object at rest stays at rest unless acted upon by a net force. Inertia is an object's resistance to change in motion. An example of this is when the clay pigeon thrower stops. The clay pigeon keeps going forward because of inertia. The second law states that when a force acts upon a mass, it accelerates. The equation for this is force equals mass times acceleration. An example of Newton's second law is a 20 gauge and a 12 gauge cell. As you can see, the 20 gauge cell is much smaller than the 12 gauge cell. This is because the 12 gauge cell has much heavier shot. So, because the mass is more, it needs more force behind it to accelerate the shot at the same rate as the smaller shot in the 20 gauge cell. It's good to know that the more mass an object has, the more force that is needed to accelerate. And the more force that you apply to a mass, the faster it will accelerate. Now for Newton's third and final law, which is for every action, there's equal and opposite reaction. In trap shooting, this explains recoil. Recoil is the force of the gun accelerating back into your shoulder after you shoot it. Because of the force propelling the shot forward, it is now equal, but with the more mass of the gun, it accelerates backwards into your shoulder. That concludes our video. We hope you enjoyed, and we hope you also learned something from it. But I would like to conclude what we just learned. We learned what speed and velocity were, and the difference between the two. We learned what acceleration is, and how that works with trap shooting. We also learned what friction was, and how that affects it. We also learned how to calculate a clay pigeon's average speed in meters per second. We also learned how Newton's first law, the law of inertia, and Newton's second and third law affect trap shooting. Again, I hope you enjoyed, and I hope you have a good day.